If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where you are solving previous year IT JEE questions on definite integral. So in this lecture we will be solving from question number 36 to question number 41. Okay, then let's try to solve these questions. Now the value of this one, 4x cube d dx square of 1 minus x square to the power 5 dx. Now if you see this one, already one term is there which is involving d, and this is, so you consider it at by parts. And how you will take which one is first, which one is second. If you remember by parts, how do I have considered that I late? The function which integration is easy, you will try to make it second function relatively. This integration is also easy, but this will be, if you further differentiate it, it will deteriorate, it will go to d square. So if you integrate this one, then this d will remove. Once this goes out, then integration looks good to me, because it is only algebra. This d is only making problematic. So to remove this one, make it second function so that you can do the integration. So if I take this is first, this is second, so what is, I am using the shortcut first function constant integration of second. So if you do integration of second one, then what will happen, this out of double derivative, it is actually double derivative, so one derivative will go, it will be 1 minus x square to the power 5 d dx it will be. Now if you put this limit 0 to 1 here, it will go 0, because if you put 1 then this is 0, if you put 0 then this is already 0. So that's why this part you can forget about. Now next, differentiation of this one and again integration of this one. What is again integration of this one? This will move now 1 minus x square to the power. Here also if you put 0 to 1, this will also give you 0. If you put 0, this is 0. If you put 1, then this is 0. So this product will be 0. Now this integration is not finished yet, because you have to, the shortcut in continues whenever until it is finished. So again you differentiate this one 24x, again integration of this one. You can do this integration here, then you continue again differentiation of 24x 24, then again integration. But I have stopped it. If you want to stop at some point, then you take integration that point and you make it again by parts. You do it separately. Now you can do it separately. You take x square as a t, you will get x dx as dt. So that you can do, I think, anytime. So it will be, if you take it to minus 2x, then if you take this one t, then it will be dt dt and t to the power 5. So t to the power 6 by 6, you put the limit 0 to 1, final answer you will get the following integral, pi by 4 to pi by 2, 2 cos is equal to something of e to the power u, e to the power minus u format they are giving. So the idea is, what is e to the power minus u? It is 1 by e to the power u. So if you take cosec x, e to the power minus u is 1 by e to the power u. From here you will, from what property of cosec you get this one, inverse of this one will also involve cosec, that is sec plus tan inverse is sec minus tan. Similarly cosec plus cot inverse is cosec minus cot. So if you take cosec plus cot e to the power u, then cosec minus cot will be e to the power minus u. From here if you solve cosec, it is e to the power u plus e to the power minus u by 2. I want to replace this cosec by this one. So similarly then I have to replace this dx also, that's why I am integrating differentiating this one. Cosec differentiation is minus cosec x into cot x is minus cos square e to the power. If you take cosec common, cosec plus cot u is e to the power u, and this is already e to the power u. So if you put e to the power get cancelled, so dx is this much, and this one you have already seen. So you put this value all here, replace all this. In case of cosec you write this one, in case of dx you write this one. Finally you will left with this one. Now I think you can easily integrate this one. If similarly you change the limit also, if x tends to pi by 4, then what will be e to the power u? U will go. If you put cosec pi by 4, it is root 2. If you put cot pi by 4, it is 1. So root 2 plus 1 is equal to e to the power u. Here you can see. So u is equal to ln root 2 plus 1. Similarly, if you put pi by 2, u will be equal to. So limit will change to like this. So that is your option A. Next, if you come to 38, if f is any function from 0 to 2, any real number which is continuous on 0 to 2 and is differentiable at 0 to 2, f0 is given as 1. Let fx equal to 0 to x square f root t dt. You think this is capital F, this is small f, you have to be very careful. But they have given one, capital F dash equal to small f dash, this is given. For x 0 to 2, if this is thing, then for all value between 0 to 2, then find capital F2. So they are asking to put 2 here. So you differentiate this one because this is given to you. So if you differentiate using Leibniz, so it will be f, instead of t you put x square, then differentiation of x square. And this is equal to this they have given. So I am writing instead of this. So from here using differential equation you can find, because you can write it dy dx and this is y. So you can write separate, or you can put this actually fx denominator, then you take integration fx t f dash x dx dt. So it will be ln t. Or you do it in differential equation format, whatever format you do, it will come like this. ln y is equal to this one. So therefore, what is y? Y is equal to your fx equal to y, that is e to the power some lambda into e to the power x square. So this constant they have given, f0 equal to 1. If x equal to 0, then output of small f is 1. So if you put that below, you will get this lambda. So that means you e to the power x equal to this. But you need to find this fx. So you put this, you find f root t. What will be f root t? E to the power, instead of x square, it will be t square e to the power t. So you put it in the integration 0 to x e to the power t dt. Finally, if you integrate, you will get your fx. They are asking you to find f2. Instead of x, you put 2, it is e to the power 4 minus 1. That is your option B. Next, if you come to 39, common question for 39 and 40. Given for each a between 0 to 1, limit h tends to 0 plus h to 1 minus h. This is given. Let the limit be GA. In addition, it is given that the function GA is differentiable or 0 to 1. Then find the value of g half. So A is given this one. So what will be g half? You put instead of a, you half. So instead of a, if you put half, then it is actually this fashion, which is this. I think you can integrate this one easily to make it a quadratic perfect square method. It will be a square minus x square sin inverse. So if you put, your answer is A. First one is very easy. Second one, they are asking differentiation of f dash half. So your GA is this one. Not integrate this one, because if you differentiate this one, because your output will be constant. If you direct differentiate, it will be 0. You cannot calculate g dash a, then you cannot put half. So what we can do, because here 1 minus t is there, you can try to put it g1 minus a. So if I put it g1 minus a, so instead of a, it will be 1 minus a. Something of, I can say it is, I am applying king rule. What I am applying? King rule. So instead of ga, I am putting g1 minus a. If you put it, it will be of this fashion. Now if you take 1 minus t equal to y, then minus dt equal to minus dy, or dt equal to minus dy, then instead of this, it will be 1 minus y, it will be t. So it will look like exactly same, this and this, if you put this. So both are equal to exactly same. Now you differentiate this one, you get some idea of g. X any expression of g, now you can differentiate. So g dash a, this one into minus a, so this equal to this. And now if you put half, it will be 2g dash half equal to 0, or g dash half equal to 0. Question number 41 is matching. So if you see the first one, the number of polynomials fx with non-negative integer coefficients degree less than equal to 2, satisfying f0 equal to 0, and this integration should be equal to 1. The number of such polynomials you can have. So degree is less than minus 2. So let's start with degree 2. So degree 2 polynomial is this one, and they have given f0 equal to 0. So if you put 0, your c will be obviously 0. So your fx for second degree, if I start from 2, it is of this fashion. So this integration they have given 1. So if you integrate this one, you will find this function as 1. 2a plus 3b equal to 1. So it is given a, b, both should be integer and non-negative. If you try to solve, if a is equal to 0, you will find 2. If a is equal to 1, then b become fraction, a equal to 2. That also not not possible. If you put 3, then it is possible. If you go on beyond a 3, then b become negative. So how many options possible? One set is this, one set is this. So there are 2 options possible. Therefore p will be connected with 2. 2 such polynomial is possible, a with a and b. If you come to the second one, it is given fx equal to this, and then you have to find the number of points in the interval this for which this attains maximum value. This should attain maximum value in this. So for maximum, you do differentiation and make it 0. So if you now write it in sine plus cos, if you take 1 by root 2, 1 by root 2, I think you can do now 1 by root 2 is that you can write sine pi by 4, cos pi by 4. Then you can apply sine a plus b. So it is sine a plus b if I am giving 1 by root 2 extra, both. So f minus will occur when I am not going with differentiation. You can do with differentiation also. So this here, what I have done, what is the maximum value you can have when this is equal to 1? So this should be equal to some multiple of pi by 2, 2n plus pi by 2. So if you see, x square should be equal to this. So you cannot put x equal to minus n minus 2, because then it will be negative. So minus 1 minus 2 it cannot be. So you can start with 0, because x square cannot be negative. So if you start with 0, so it will be pi by 4 plus minus pi by 4, which is within your minus root 13 to plus root 13. Then if you put x equal to 1, then you are getting with this one. This is also again with, so 3 pi by 2 is within minus root 13 by 13, so that's why it is also answer. If you put n equal to 2, n equal to it is root 17 by pi by 4, it is not under root 13, because it is coming 53 point something divided by 4 more than 13. So therefore how many solutions are there? 1, 2, 3, 4. That's why question number 3 will be linked with 4. Then PQR, the R is given, I is given this one, you need to find the value of this one. if you put that q in rule, a plus b minus x, minus 2 plus 2, then is minus x, that is 0 minus x. So instead of x it will be minus x. I think you have solved this type of, so then you add these two. If you add the two, 3x square common, that it will be 1 plus e to the power x by 1 plus e to the power x. It will be only 3x square. If you solve it, it is 8, so it will be connected, r will be connected with option 1, that is 8. Next the s, this one, minus up to have this divided by this. Now if you once you see this one, you always try to with even or not. So this is already even, you know. Now you have to find this one. Now if you see this one we have solved same type in question number 28. We have shown this is odd in 28 number question. So this will be odd. So even into odd, if you do integration, it will be 0. So in numerator it is 0, and denominator it is not 0 because it is 0 to half. If it is minus half to half, then it is 0. So 0 to half, it is not 0. Total is 0 if it is an odd function. So numerator is 0 but denominator is not 0, so its answer will be 0. Therefore s is connected with 4. If you like the video, then press the like button and please give your valuable comments in the comment section.